Hello, today we are going to derive the velocity of sound wave in a medium. Newton derived this equation for the velocity of sound wave. Velocity is equal to under root modulus of elasticity divided by density of the medium. But Newton assumed an isothermal condition and he derived the velocity of sound wave to be equal to 287.5 meter per second, which does not agree with the experimentally calculated value, which is 332 meter per second. After Newton, Laplace used a correction and he correctly determined the value of sound in a medium. Now let's discuss about the Newton method. Newton assumed an isothermal condition and ignored the effect of temperature. Newton assumed that the sound travels through air and other gases under isothermal condition, which means that when the sound waves travel in the air, there is no change in temperature. Under such a condition, the modulus of elasticity is equal to the pressure of the gas, which can be proved. Let's assume the Boyle's law, we have pressure and volume. Now let's consider when we change the pressure P by plus del P, when we increase the pressure, the volume of the system will decrease. So when we substitute P is equal to P plus del P, the amount we changed, we increase the pressure, then the volume will decrease, and let's assume the volume is equal to V minus del V. Substituting these values for pressure and volume, in this equation we will have PV is equal to P plus del P, V minus del V. Now multiplying these terms, P plus del P and V minus del V, will give P multiplied by V and then P multiplied by minus del V. So we have minus P del V. Now multiplying this term del P with V, we will have plus del PV minus del P del V. Now in this equation, the PV term will cancel out with PV, pressure and volume, and here when the change in the pressure is very small, then the change in the volume is also very small. So we ignore this term and we will have two terms, minus P del V plus del PV. Del PV is equal to 0. So we have ignored this term and we will have P del V is equal to del P into V. Now dividing both the sides of this equation by del V, we will get pressure is equal to del P times volume divided by the change in the volume. So we will have pressure P is equal to change in pressure times original volume divided by the change in the volume. And shifting this original volume term to the downside, we will get del P divided by del V divided by V. Here the del P represents the change in the pressure, which is stress, and the del V, change in volume divided by original volume, is the volumetric strain, and this pressure is equal to the modulus of elasticity E. Now replacing this modulus of elasticity in this equation with pressure, we will have velocity of sound wave is equal to pressure divided by density of the medium. Now substituting the value of atmospheric pressure, this is the value for atmospheric pressure, and substituting the value of density of the air, which is 1.2 kilogram per meter cube, and solving, we will get the value of 287.5 meter per second. So this is the velocity which Newton determined for the speed of sound, but experimentally the value of sound speed is 332 meter per second. Laplace solved this problem and he used an adiabatic condition. He assumed that when the sound waves are traveling through a medium, they compresses the air, and when the air compresses, the temperature of the system increases. So Newton ignored this fact, and Laplace used this term gamma. So Laplace used the adiabatic process where pressure times volume power gamma is equal to constant. Now again here, when we change the pressure, when we increase the pressure by del P, it will decrease the volume by del V. So we have PV whole power gamma is equal to P plus del P into V minus del V power gamma. Now solving this equation, we will have P plus del P and taking V power gamma common from this side of the equation. By taking V power gamma common from here, we will have 1 minus del V divided by V whole power gamma. Now this V power gamma term will cancel out with this V power gamma, and we will have pressure P is equal to P plus del P, change in the pressure, into 1 minus gamma del V divided by V. Now this term, this is the binomial expansion. We have considered only the first term and ignore the higher degree terms. So 1 minus del V divided by V whole power gamma is equal to 1 minus gamma del V divided by V. Now multiplying both of these terms, we will get pressure P is equal to P minus P gamma del V divided by V plus multiplying del P with 1, we will have del P, and then multiplying this change in the pressure with this term, we will have minus del P into gamma del V divided by V. Now this P will cancel out with this P, and again here, when the change in the pressure is very small, the change in the volume is also very small. So we have ignored this final term, and we will have only these two terms, minus pressure time gamma change in the volume divided by volume plus change in the pressure is equal to 0. Now shifting this term to the left side, we will have change in the pressure is equal to pressure into gamma time change in the volume divided by volume. Now doing cross multiplication, this volume will multiply with the change in pressure, and dividing both sides by del V, we will have del P time volume divided by change in the volume. And now moving this term back to the downside here, we will have gamma time pressure is equal to change in the pressure divided by change in the volume divided by original volume, where this is the volumetric strain and this change in the pressure is stress. So we have modulus of elasticity is equal to gamma time pressure. Now substituting the value of gamma time pressure in the velocity of sound wave equation, which is V is equal to under root E divided by rho. This E is the modulus of elasticity, and this rho is density of the medium. Now here again substituting the value for pressure, atmospheric pressure, atmospheric density, and the value of the gamma here is 1.42, and this 1.42 depends on the medium. For the case of air, this value is equal to 1.42. Substituting these values and solving, we will get 333.5 meter per second, and this is nearly equal to the experimental value. Now the velocity of the sound wave depend on the medium, on the density of the medium, on temperature of the medium, and moisture and pressure of the medium. So there are a lot of things that can affect the velocity of sound wave. Thank you for watching, and do not forget to subscribe easyedu for more videos.